Networking is an essential part of the IoT ecosystem. Even the name Internet of Things exposes the fact that IoT devices are to be connected to the global or at least local network. IoT networks are divergent. Sometimes they mimic Internet as we experience while using desktop computers, tablets, and smartphones. Sometimes those are dedicated networks operating on different principles, usually because of the end node's performance constraints such as a low amount of random access memory, small storage, and low performance CPU core. A physical distance and networking conditions between remote nodes and Internet gateways are also a key issue when planning the IoT network solution. Most of the IoT devices use wireless protocols to send and receive the data. By the dedicated IoT, specific protocols like 6LoWPAN or LoRa that are out of the scope of this lecture. One of the most popular protocols is well-known IOT-2.11 standards, referred to as Wi-Fi. Wireless connections are applicable in remote locations and are the common solution for battery-powered devices. For the short-distance communication, some 10 to 30 meters, a common choice is Bluetooth protocol, requiring less power than Wi-Fi. Bluetooth develops instantly, and over each new version of the protocol, there are more and more advanced capabilities, like in example mesh networking starting from the most recent Bluetooth 5.0 specification. By the wireless networks, there do exist wired solutions like using Ethernet-like interfaces, in example Arduino Ethernet Shield, but that is the minority in the end node devices. Wired networks are used commonly in the gateways, where the high reliability of the connection is crucial for the operation of the critical network infrastructure devices. Some of the devices we use during our course and their connections capabilities are listed in the table below. Parallelly, there are GSM modules that can be connected to the system on chips and development kits using usually serial protocol. Serial network connections are an option, particularly when implementing a large network with physically distant nodes, where setting up dedicated Wi-Fi or similar infrastructure is limited mostly because of the economical reasons. GSM networks has a serious disadvantage, however. It's a need to achieve a license for the operation or to purchase third-party operators' plan. Also, GSM handshaking requires quite a lot of power, even sometimes 5 watts to initiate the connection. The most common use of the GSM interface is sending and receiving SMS messages with the payload containing some information, usually sensor data or just a device state. Regardless of the aforementioned connection methods, there are two communications models. One where there is a continuous connection between actors, referred as TCP connection, and the other one, so-called datagrams, where you send data from time to time in short packets referred as UDP. To easily present it, the continuous connection is similar to the phone call when you stay in touch with other person talking to it and hearing instant feedback, while datagrams are like sending SMS messages. For a deeper review of the possible solutions for IoT networks and protocols, please join our course on Advanced IoT Programming. In this lecture, we present a simplified approach where there is a running TCP connection between the IoT devices and the network infrastructure. Devices are, or actually can, open a communication channel using IP address. TCP/IP connection establishing and handshaking is specific to the hardware solution used and refers to so-called networking layers in the protocol stack. Please refer to the further sections of this lecture presenting on how to establish programmatically a TCP/IP connection in various schemas using ESP system on chip. Assuming you have a running TCP connection between your IoT device and the Internet or intranet now, it is time to get familiar with one of the most common application-level IoT protocols, that is message queuing telemetry transport, shortly MQTT. MQTT is an application layer, text-based, lightweight protocol designed especially for the IoT. It is somehow similar to the HTTP idea, but far simpler and designed for the constrained devices. MQTT is also suitable for unreliable networks and networks with low data rates. Nowadays, there are various libraries implementing MQTT on almost any IoT platform, including Arduino and ESP. There are graphical applications for Windows, Linux, and Mac that directly communicate in MQTT to simplify development and testing. MQTT uses publish-subscribe model and requires an MQTT broker server that is a communication center for all devices exchanging data in the IoT network. Interestingly, Facebook Messenger was using a clone of the MQTT protocol for the messages exchange.